Here's the first example. It says find the length of BC to the nearest hundredth. So BC is this line here. I am going to look first in order to find my ratio. I'm going to look to see where my angle is. I'm going to call BC X. From my angles, I have AC and BC. I'm going to start by labeling my triangle based on this angle. So the adjacent, the hypotenuse, and the opposite side. So the hypotenuse is what I label first because it's across from the right angle. Then I'm going to label the opposite side. That's the one across from the angle that I'm using. Finally, I'm going to label the adjacent side. So what I can see is that the sides that I have are the opposite and the adjacent. The value that uses opposite and adjacent is tan. So now I'll set up my equation. I have tan of 15, because it's 15 degrees, is equal to opposite over adjacent. Now I want to solve for x. How this is going to work is tan 15 is going to be one term that I keep together. I'm going to move x over. So to get rid of this fraction is I'm going to multiply both these sides by x. So I end up getting tan 15x equals 10.2. I still want x by itself. So in order to do that, I'm going to divide tan 15 by both sides. Then I'm going to get out my calculator. You will have to use a calculator on these. I'm going to plug in 10.2 divided by all more advanced, like scientific calculators, you're going to see 3 buttons that say sine, cosine, and tangent. Remember, you need to be in degrees for this to work out correctly. I'm going to press tangent. My calculator says tan and gives me a parentheses. Then I'll fill in 15 and then press answer. I get 38.07. Then I'm going to look at my problem and make sure that 38 is a length that makes sense. It's logical that that side is 3 times that 10.2. So 38.7 totally makes sense. Also now see that the units are in feet. So we are working through these slowly in order to find what those side lengths are.